series. We are going to begin today by talking about solutions, and we're going to jump right in. We've talked last time about expressions, and that is anything where we combine terms. So 5 plus 4x is an expression, and then 6 minus 9x is also an expression. Now, what an equation is are two expressions combined with an equal sign. And what that means is 5 plus 4x is equal to 6 minus 9x. Now, we can take these equations and determine what are the solutions to these equations. For linear equations like this, where you have just, let's say, one variable, and that variable doesn't have any exponents, and then maybe a constant term, if you remember from geometry, you can have lines, and there are kind of three situations for lines. You can either have lines that are parallel, they look like that, and they never cross. If this is the case, then there are zero solutions. You can have lines that cross once, and this is when you would have one solution. And then you can have lines that are exactly the same. They're overlaid on each other, and that means you have infinitely many solutions. And so in the same way, these actually correspond to lines in the plane. So you'll either have zero solutions, one solution, or you'll have infinitely many solutions if they're the same. So just keep that in mind. There's no way for there to be like three solutions for one equation that's just linear like this. So let's actually go in and start calculating what the solutions are, and how to determine if something is a solution. So let's start out with a relatively simple one. Is v equals 2 a solution to the equation 4v minus 2 equals 16. Actually, I'll do 6. The way you do this is a very a method that really shows what a variable is. So we talked last time about the definition of a variable and how to determine the variables in an expression. This time we're actually going to say, well, for this variable, which can vary, or that's where the variable comes from, it can vary the value. Whenever we have a particular value, does it make the equation work? And that's what a solution really means, is does the equation work? Is it true? So we need to remember that, first of all, in order to solve this, we need to make sure we remember that if we have 4v, what that means is 4 times v. Okay, so that's our first piece of information, is the actual equation itself. And I'm going to put this in a little box. 4v minus 2 is 6. With just the equation, we don't have anything to check, but we have another piece of information, and that is that v is equal to 2. So since v is 2, we can go ahead and plug in 2. So 4v means 4 times v, so this means 4 times 2. Minus 2 equals 6. And then we just solve from here using the regular order of operation rules, PEMDAS, as you've probably heard it. So we do multiplication first, and then we do the subtraction, which is 6 equals 6. Now, if it comes out, whenever you plug this in and it comes out and it's true, it looks reasonable. So this is reasonable, right? 6 is 6. We're going to put a check mark there and say, yes, v equals 2 is a solution. But let's go ahead and look at, this particular equation is only going to have one solution. So let's go ahead and look at if v was any other number. let's say, and I'll do it on the same page here. What if v was 3? Then we have 4v minus 2 equals 6, where v is 3. Then we have 4 times 3 minus 2 equals 6. 4 times 3 is 12. Minus 2 is 6. 12 minus 2 is 10, sorry. 6. And we get down to something that makes no sense. 10 is not equal to 6, or at least I hope it's not. So, since it doesn't make any sense, we say no, it is not a solution. So v equals 3 is not a solution, but v equals 2 is. It all comes down to, does that value make the equation make sense? So these, as you might expect, can get a little more involved, a little more complicated. So let's say, is 5 a solution to the equation (3b minus 5 equals 6b plus negative 20. And remember, remember the rule that adding a negative is the same thing as subtracting. I personally prefer to add negatives because it tells me, what the inverse of something is. But if you prefer subtraction, that's fine. Here I'm mixing both of them, but just understand that it's the same thing. So let's go ahead and rewrite this using all one method. So 3b, let's say minus 5 is 6b minus 20. Now we're going to plug in, this doesn't say specifically b equals 5, but if there's only one variable, then it's implied. So b is 5. There's nothing to simplify on either side of these, so we're just going to go ahead and plug them in. We're going to go 3 times 5 minus 5 is 6 times 5 minus 20. 3 times 5 is 15 minus 5. 6 times 5 is 30 minus 20. 15 minus 5 is 10. 30 minus 20 is 10. So we get down to something that makes sense. So yes. So if it makes sense at the end, then it is a solution. Again, if it doesn't make sense, then it won't be a solution. So that's how you, in general, check, is something a solution? Now, it's a little bit cumbersome to go through and check is whenever you have something, like imagine you're just given, this equation, it would be very cumbersome to go through and say, is 1 a solution? Is 2 a solution? Is 1/2 a solution? Is -3 a solution, right? There are just way too many numbers that we're actually going to have to check. So again, we're either going to have, going back to this, we're either going to have 0 solutions, 1 solution, or infinitely many. If we have 0, it'd be nice to know we have 0. If we have 1 solution, again, it would be nice to know what is that solution. And if we have infinitely many, then that would also be good to know. So let's go ahead and add a new page here and talk about how we actually determine what the solutions are. So the way we're going to do that is first noting something in particular, a particular property. And that is, let's say we have an equation. We're going to start really simple. 2 plus 2 equals 4. All right, I think everyone would agree this is true. What happens whenever I add 1 to both sides? 1. Well, we have on the left side 1 plus 2 plus 2, which is 5. And on the right side, we have 4 plus 1, which is 5. So interestingly, whenever we add something to both sides, it's equal to the same thing. So if we start with a true expression, add something on both sides, then the expression remains true. Okay, now what if we take and multiply both sides by 2, the entire thing? Well, on this side, we already know this is 5, so we have 2 times 5. And we have 5 times 2. So again, we're getting something that is equal. So if we add, and subtracting is really the same thing as adding a negative number, or subtract. Both sides, rather 2, both sides, the equation is still valid. If we multiply or divide, remember division is just multiplication by a fraction, to both sides, not to both sides, but both sides, and we have to do the entire expression on both sides. The equation also is still valid. So we can add to both sides like we did here with the 1, and it's still the same. We can multiply the entire side by some value or divide, like I said, and it's still going to be valid. So keeping that in mind, we're going to use that particular piece of information to solve the equations. So we're going to start with what are called one-step equations. Solve x plus 8 is 17. Now, I'm just going to copy this down here. I said that if you add something to both sides, it remains the same, right? The equation is still valid. So what happens here if we add, well, and let me say down here, what we want to get to is x is equal to something, right? Because we're trying to solve for x, we want to know what is x. So we want x is equal to something. So somehow or another, we need to get x by itself on one side of the equation. So if we just happen to add negative 8 or subtract 8, whichever you prefer, and we add negative 8 to both sides, the equation's still valid, right? We still have a valid equation, just like we said. But we have x plus 8 plus negative 8. Well, that's just x, right? Because the 8's cancel out. They add to 0. And then on the right-hand side, we have 17 plus negative 8. Well, that's just 9. So look, we did it. Just by adding the same thing to both sides, we were able to solve for 9. X is 9. So let me show you what that looks like. Let's verify it's a solution. You don't always have to verify it's a solution because it's going to be, right, if you did everything correctly. But let's go ahead and check to make sure whenever we plug it in, things make sense. So let's plug in 9 to this equation. 9 plus 8 equals 17. Left-hand side adds to 17. It is a solution. If we plugged in 10 instead of 9, we would have 10 plus 8 is 17, which is 18. 17, that doesn't make any sense. Not a solution, right? So we know that we have one solution, right? Because we found it here, 9. And we know there aren't infinitely many because we checked, and this one isn't. So there's exactly one solution to this equation, and we found it. It's 9. It's pretty powerful stuff. So let's go ahead and look at another problem. And the more problems you do of these, the easier they become. Solve 27 is equal to, let's do a minus 16. So we have 27. Let's just go ahead and copy it down. It's a minus 16. we need to somehow get a by itself. And the way we can do that here is we're saying take a and subtract 16. So if I have, let's say, $3, those are dollars, believe it or not. If I have $3 and I take away $1, so I have, cool, I didn't know you could erase like that. And I take away $1, then I have 2, right? And so if I add that dollar back, I'm back to what I started with. So what I just did is I said, if you take a dollar, let's represent a dollar by X, and we had 3 of them, and I take off one of them, and then I add that one back, I had what I started with. And that's just because 3x minus 1 plus 1, those two cancel out, and you get 3x. So in the same way, what we've done is, we've done, and I guess I can just do this. That's so cool. Okay. What we've done something to a. We've subtracted 16 from a to get 27. So the way we undo a subtraction, the way we undo something that's been done, is by adding 16. Right? If I have something and I take away 16 and then I add 16, I've effectively done nothing to that thing, which is what we want, because these two things will add to 0. And of course, we don't have to write the 0 there. And we have to do it to both sides. 6 and 7 makes 3. Carry the 1. We get a is 43. Again, just for fun, let's check it. 43 minus 16 is 27. So 27 is equal to 27. Cool. Now, these are going to be, in everyday life, you won't be seeing things like this. What you'll be seeing, let's go ahead and move on to what you'll be seeing kind of in everyday life, is an equation like the sum of 5 and 7 is 12. Right, and this is definitely a true statement, but how can we verify it's true? Well, we have to go through and pick out, how can we write this as an equation, is what I mean by that. The first thing we need to do is go through and pick out, an equation has an equal sign, so where is the equals in this? And in this case, the word is. Words that will give you, the equal words is, I think, what the lesson calls it. We have is, gives, makes, forms, anything like that. The sum of 5 and 7 is, the sum of 5 and 7 gives, the sum of 5 and 7 makes, the sum of 5 and 7 forms. Anything that is of that kind of flavor is going to be your equal sign. So the sum of 5 and 7, that means addition. Sum is addition. So the sum of 5 and 7, 5 plus 7, is equals 12. And that is a true statement. So now we're going to work on some examples using these what are called word problems to solve equations. So for example, 2 times the difference of x and 9 equals 16. This is a whole lot more of a complicated riddle, if you will. So first thing we got to do is go pick out the equals word. And we have it. We have equals kind of spelled out here for us. And cut off the E. It's a 9. Next thing we need to do, so we can go ahead and write our equals, let's say right here. And we see another indication in here of the operators. So let's go find the operators. We have times and we have difference. That tells us that there are some operations we need to be doing. Difference means subtraction. And so we need to make a note in here. 2 times the difference. That means by the time we get around to multiplying by 2, the difference has already been taken. And so if we just wrote, let's say 2 times the difference of x and 9, the difference of x and 9 is x minus 9. And then if we just wrote 2 like that, we're doing 2 times x minus 9. We're not doing 2 times the difference of x and 9, right? We're doing 2 times x minus 9, which would be incorrect. What we need is for the difference to happen first, and in order for it to happen first, according to our PEMDAS rules, our order of operations, they need to be in parentheses. So 2 times the difference of x and 9 equals 16. And so it's good once you get your equation written out, just kind of say it out loud to yourself without looking at the problem. You say 2 times x minus 9 equals 16. So 2 times the difference of x and 9 equals 16. It makes sense. It checks out. Now this is going to be actually multiple steps here. It's not just a one-step equation anymore. And just like I said earlier, how whenever you can multiply both sides in order to and still have a valid equation, we're going to do that here. So what we have is this entire side is multiplied by 2. We're trying to get x by itself, remember, so we need to undo the operations done to it. And I should back way up and say we have PEMDAS. Right, multiplication and division are really the same operation. Addition and subtraction are really the same operation, right? Division is just multiplication by a fraction. Subtraction is just multiplication, it's just addition by a negative number. So whenever we were doing something to this x, we followed PEMDAS, right? First thing we're going to do is the parentheses, which is x minus 9, and then we're going to do multiplication. So we went this way. Whenever we're solving these equations, let me figure out how to get that off. Whenever we're solving these equations, we want to go the other direction, right? Because we're trying to undo what's been done. So we started going this direction. To undo that, we need to go this direction. Right, so the first thing in this, do we have any addition or subtraction? Well, no, because we have this in parentheses, right? So the parentheses, what's inside the parentheses, this addition and subtraction on x, is it's simplified. There's nothing more we can do to it, if that makes sense. So the next thing we look for is multiplication and division. Well, we do have multiplication, right? We have multiplication by 2. And so, let me get rid of PEMDAS here. We can multiply both sides. How do we get, I guess let me ask this. How do we get rid of multiplication? How do we undo what we've multiplied? If I have, and this is kind of a silly example, if I, again, have $3, and I double my wealth, I now have $6. How do I undo that? Well, I need to take this overall quantity and cut it in half, right? So we multiplied by 2 to get 6, and then we're going to go back and half it to get back to 3. So in the exact same way, what we've done is we've multiplied this quantity by 2. We need to undo that by multiplying both sides by a half times. And what I'll do is I'll actually put a half over here. So a half times 2 of a half times 2 lots of something is just that something, right? And that was the whole point of multiplying by a half. We doubled something, and now we're going to multiply by a half. And then 16 times 1/2 is 8. Now, we have x, and subtraction has been done to it, and that's all that's been done to it. So the way we undo subtraction is addition. It's all about the art of undoing, solving these things, is 17. So there you go, x is 17. Again, let's go back through, make sure everything makes sense using our PEMDAS rules. Plug in 17, we get 2. 17 minus 9 is 16. 17 minus 9 is 8. We get 16, 16. Boom. So that works. 17 is good. Okay, I think I want to do one more problem, and then we'll wrap it up for today. And I'm going to take this directly from the lesson because I think it's a useful one, and that's going to be 6 less than x is equal to, I think I said the homework, I meant the lesson, 38. So 6 less than x. So let's say 6 less than 10 is 4, right? And the way you calculate that is you did 10 minus 6. So 6 less than x is x minus 6 is equal to 38. So we have x, and to undo that subtraction by 6, we need to add 6. We just get x on the left. 38 plus 6 is 44. So I don't know why Lumen has done this, but it looks like they've thrown in these two-step equations as well. I wouldn't worry a whole lot about what we did here with these two-step equations, apart from just knowing how to set them up, like what we set up right here. That's my mistake. I probably should have just set it up and not solved it. We'll get to this at a later point. But as far as actually doing these problems, these one-step equations, just know it's all about the art of undoing. I said I would do one more. Let's do one more just to make sure that I've hammered in what these two-step equations are. Let's say twice x is 4. So twice x, if I say twice 3, that's 6, right? And the way you got that was 2 times 3. So twice x is 2x is, which is equals 4. Now we have x, it's been multiplied by 2, so the way we undo that multiplication is, you can think of it as division by 2. I'm going to think of it as multiplication by a half. And what we get is 1/2 times 2x is, and I'm sorry, I shouldn't use that x. Multiply both sides by a half. Remember, that doesn't change the validity of the equation. 1/2 of 2x is x. 1x, right, which is the same thing as x. And then 4 times a half is 2. X is 2. So that's how you set up these one-step equations. We even, like I said, went through a two-step equation, which is something we'll be dealing with more in the future. But for right now, just know how to take these word problems, set up the equation, like what we did here. Even though it's a two-step equation, just make sure you know how to set up those equations. And then also, whenever we have these, 6 less than x is equal to 38 types of word problems, know how to set those up and solve them. That's going to be it for today. Next time, we're going to be jumping into prime factorization and what the least common multiple is, so that'll be a lot of fun. Hope everyone has a good rest of their day, and